Good day, everyone. Welcome to my YouTube channel. So today, let's look at this integration. And so, in integrations, if you ask to integrate this x raised to the power of n with respect to the x, so while integrating, you add 1 to the power, and then you add 1 to the power here. You know, in differentiation, you subtract 1 from the power. While in integration, you add 1 to the power. And so that was what I did here. You will now divide by everything that is there. This n plus 1. After you have added the 1, it becomes n plus 1. So you now divide by n plus 1, which is this. Include your constant, please. Whenever you are integrating, include your constant. So take note that whenever you integrate 1 over x with respect to the x, whenever you integrate 1 over x, it will give you ln x. And as I've told you that you must include your constant. And whenever you integrate exponential x, it will also give you exponential x. And whenever you differentiate exponential x, it will also give you exponential x. Whether you integrate or you differentiate, it will give you exponential x. But the difference is that whenever you integrate, just make sure that you do what? You include your constant. So let's look at example 1. And then this, let's solve it here. We have to integrate x raised to the power of 7 with respect to what? X dx. So let's integrate. As I've said that while integrating this, you will add 1 to the power. As I've said, you will now divide by everything after you have added the 1. Everything that is here. So let's integrate this. This becomes x raised to the power of 7 plus 1. You will now divide by what? Everything that is here, which is what? N plus 1. That is 7 plus what? 1. 7 plus 1. Just make sure that you do what? You include your constant. So this gives us x. 7 plus 1 is equals to what? Is equals to 8 over 7 plus 1 is equals to 8 plus c. That is our final answer for that. So let's look at question number 2. In question number 2, we are integrating. In question number 2, we are asked to integrate this. So we have the integral root x dx. So whenever you are integrating this, one thing I want you to take note is that this, you can also rewrite it as this. You can also rewrite it as x raised to the power of x raised to the power of 1 over 2 dx. You can also rewrite this in this way. This is raised to power. This 1 over 2 is the power. Whenever you are asked to find the square root of 100, you can also write it as 100 raised to the power of what? 1 over 2. You understand? And you know, this is power, right? So if you now bring it like this, if you solve it like this, now you know you can write 100 as what? 10 raised to the power of 2. Mind you, this 10 raised to the power of 2 is the same thing as this 100. Now write the power here. So if you should use this power inside to multiply the power outside, it will give us what? 10 raised to the power of 2 times 1 over 2. So these two, we cancel these two. Right? 1 times 1, 1. 1 over 1, it will still give you 1. So we are left with 10 raised to the power of 1. And 10 raised to the power of 1 is equal to what? 10. So, and you know that 100, the square root of 100 is also known as what? 10. So you can also rewrite this as this. So let's integrate. As I've said that while integrating, you add 1 to it, and you also make sure that you add your constant. And so this one will give us x raised to the power of 1 over 2 plus 1, everything all over what? Over everything that is there, over 1 over 2 plus 1. Make sure that you include your constants. So this gives us when you add 1 plus this, it's just like 1 over 2 plus 1. So you can write this one as over 1. You understand? So when you find the LCM of 2 and 1 will give you what? 2. So 2, these 2 goes in this 2 how many times? 1. 1 times 1 will give you 1 plus 1 goes in this 2 times. 2 times 1 will give you what? 2. So to give you what? 3 over 2. So this one will become what? X, everything here will become raised to the power of 3 over 2 over, since what is here is the same thing as what is here, we also have 3 over 2. Make sure that you do what? You include your constant. And you know, so let's simplify further. We have taking this, everything that is at the up here as a numerator, while this as the what? Denominator. This is the division line. So let me write the numerator, which is x raised to power of 3 over 2, right, as the numerator. Numerator, this line, it means division line, so divided by the denominator, which is 3 over 2. Just put them into bracket like this. Include your constants. So here we have 3x raised to power of 3 over 2. When this one change to multiplications, these two will go up, this 3 will come down. 2 over 3 plus c. So if you should use this 2 over 3 to multiply this, mind you, you use this to multiply this x, not the power. You understand? So if you use this one to multiply this, it will give you 2 over 3 x, just multiply with this x raised to power of what, 3 over 2 plus constant. So that is our final answer. So let's solve that is the end of question number 2. Let's solve question number 3. In question number 3, we're given a boundary conditions. We're given boundary conditions. We have integral. This one has the boundary conditions. It's very simple. The x. So as I've said, you are integrating this first. While integrating, you will add 1 to the power. So just leave this boundary first. We want to integrate now. We have x raised to power of what? It has a power of 2. Just add 1 to it plus 1. And you now divide by what? Everything that is here. 2 plus 1. As I've said, include your constant plus the constant, right? But because of this boundary condition, so you put everything into bracket. Put your boundary conditions. The lower limit is what? 0. While the upper one is what? 1. You understand? What does this thing tell us is that anywhere you see x, this boundary condition, because you are integrating x, right? So they represent the value of x. You understand? So they represent the value of x. Anywhere you see x, you will substitute it to 1. And anywhere you also see x, you also substitute it to what? 0. But this one will be the lower limit. This one will be the upper limit. So let's simplify. We have x, this x, 2 plus 1 will give you 3 over 3. Include your constant plus constant. Put everything into bracket. Sorry, 0 is 1. So now I want to substitute our limits into this. But what you have to know is that upper minus what? Lower. So this is the upper one, this is the lower one. For the upper one, you are going to write this thing into 2 times, like into 2 places. First of all, let's rewrite it as x raised to power of 3. Sorry, yeah, you are going to write this first. You substitute the upper inside it. So this one, if you substitute 1 to the value of x, we have 1 raised to power of 3. Of course, when x is being represented by 1 over 3 plus c. Mind you that you will subtract, we said upper minus what? Lower, minus lower. We also, because this equation is what we are using for both of them. So let's substitute a 0 into it again. Now, we at the first one, for the upper one, you know, this one is upper, this one is lower, this one is at the top, this one is at the lower. So for the upper one, we represent it with 1 first. This for the upper. For the lower one, we now represent x to be what? With 0. So let's substitute a 0 now. Let's substitute a 0 into it. We have what? 0 raised to power of 3 all over 3 plus c. You understand now? So 1 raised to power of 3 is 1 times 1 times 1. That will be 1 over 3 plus constant. So we have minus 0 raised to power of 3 becomes, everything becomes 0. You understand? So when everything becomes 0 plus constant. So we have 1 over 3 plus constant. Now, when you use minus, you know, this 0 has cancelled, it has gone, leave the 0. When you use this minus to open this bracket, we have minus this one, this what is it called? C is the owner of this plus. So minus times plus, it will give you what? Minus C. You understand? So plus C minus C will cancel each other. This and this will cancel each other. We are now left with what? 1 over 3. So our final answer is what? 1 over 3. And the correct answer here is what? Option A. That is the correct answer. So let's solve question number 4. we're given that we have to integrate this t dt. So this one, you can also mind you that take note of something. Oh. This theory is under this space, oh, not outside. This is different from this. It's different from this because this theory is outside, but this theory is inside here. So you can also rewrite this as c, write it first. This one will become 1 raised to power 1 over what? 3. So what if here is 4? It will become what? Raised to power 1 over 4. What if here is 5? It will become what? Raised to power 1 over 5. I hope you get that. Okay, so the t. So as I've said, that while integrating, you add 1 to the power. So we have t raised to power of what? 1 over 3 plus 1. Everything over what? You divide everything by what is said, which is 1 over 3 plus 1. Mind you, remember to include your what? Your constants. So if you solve this one, 1 over 3 plus 1, just assume this one is also the same thing as this. Find the LCM of this and this to give you 3. So if you should simplify this, it will be what? 1 plus 3, that will be 4 over 3. So this one will give you t raised to power what? 4 over 3 over, since what is there is also the same thing as what is here, you have 4 over 3 plus constants. So if you should use this approach, the approach I use here, if you use it here again, we have this, taking this as the numerator, while this as the denominator, we have numerator, which is 4 over 3, divide, this line means divided by the denominator, which is 4 over 3, plus c. So if we are, this one now change to, sorry, if this one change to multiplications, this thing will go up, therefore will come down, that will be 3 over 4 plus c. So if you should use this 3 over 4 to multiply, we have 3 over 4 c raised to power of what? 4 over 3 plus c. So that is our final answer. That is our final answer. I think that's our final answer. Our final answer, our correct answer is option number C. Option C is the correct answer. So let's look at number 5. So one thing I wanted to take note is that whenever you integrate sign, you know, surely you get cos, and whenever you integrate cos, you also get sign. But one thing I wanted to know is that the sign will be different. The sign. For example, you know, whenever you differentiate sign, you will get what? Positive cos. That is, it will just be cos. Without let's say you differentiate sign x, it will give you cos x without having negative sign. But whenever you integrate sign x, it will not give you cos x, it will give you what? Minus cos x. You understand? So the same thing, you know, whenever you now, let me come back to cos now. Whenever you differentiate cos, let's say you differentiate cos, it will give you what? Minus sign. That is differentiation. But coming to the aspect of integration, whenever you integrate cos, it will not give you minus sign, to give you what? Ordinary sign. You understand? So that is just it. So if you integrate this, it will give you what? What will it give us? It will give us minus sign. So I hope this video is helpful. Please kindly like, subscribe, comment, and share to your loved ones.